believe we are now live. So hello, everyone, and welcome to another webinar with us. We're all very happy that you've decided to come join. I'm very excited to have with me Tiexin. Tiexin, how are you doing this evening for you?
Yeah, I'm doing great. At the moment, it's like, I don't know, like 12 o'clock in the evening. So, yeah, but I'm excited.
Oh, we appreciate you staying up for us. We really do. So Tiexin has been working as a content writer with some of us at GitGuardian for a few years now. We actually we found Tiexin because he's got quite a famous blog on Medium. We loved his articles, and we asked him if he could maybe share some of them with us. And since then, he's been on webinars before. He's a true expert in many things. So it is great to have Tiexin with us. Just while we're waiting for everyone to join us here, let us know whereabouts you're tuning in from. So for me, I'm tuning in from Utrecht. It is in the Netherlands, just near about 30 minutes away from Amsterdam. If you're not familiar with where the Netherlands, Tiexin, it's midnight where you are. Whereabouts are you tuning in from?
Yeah, at the moment, I'm in China. To be specific, southwest China, Chengdu. It's a big city, over 20 million people, but I don't think it's very famous around the world. Yeah.
We're just discussing that China has a lot of massive cities that it's hard for us in our small European towns to comprehend. But here we are. We've got some Frankfurt, Germany, from Paris, Scotland, Slovakia. Well, these are some ones that I haven't seen very often. Scotland and Slovakia are India, Dubai. Oh, that's great. Some more from Germany. We don't have anyone from America here at the moment. Someone can't hear anything. Is that is anyone else having audio trouble? Well, I guess you can't let me know. But if you can hear me, people are answering from the chat. Audio is good. Okay, I'll put that down to just that a person's user. Oh, here we are, Texas. All right, we got some from USA. Here we are. To unmute, we have more people that can't hear. So some people, okay, so many people can't hear. Tiexin, you can hear me though, can't you?
Yeah.
Unmute. Okay. So I don't think so. I think the unmute is not. We're getting some saying audio is fine. Some people saying it's not. I don't think the unmute's for us. I think perhaps the video is muted on their side. Anyway, we'll move on because it seems to be not something we can fix at the moment anyway. But if you are having, if you can hear me, then hopefully everyone can hear us loud and clear. So a little bit about what we're going to be talking today. We're going to be talking about IaC, or Infrastructure-as-Code. And we're going to be talking about some IaC best practices. Well, Tiexin is going to be talking about some best practices. We're going to be talking about how it relates in security as well. And then we're going to do a little bit of a demo of what some IaC security scanning looks like. Now, finally, at the end, we're going to have time for questions. Now, just to let everyone know, next to the chat is a button that's for Q&A. And for the Q&A section, you can add questions in here if you want. Now, we're going to answer them at the end, but as you're thinking of questions throughout the webinar, please go ahead and just ask these throughout. You can upvote other questions and all of that. Tiexin, I'm just going to mute you because I can hear myself through your microphone. I'll unmute you in a minute. But so please ask questions along the way. The other thing to mention is that there are going to be prizes. Sometimes the Amazon gift cards, sometimes the actual prizes. It really just depends on where in the world you live. So everyone is eligible. It's not just certain countries. But your prize may depend on where you live and if we can get an Amazon gift card or if we can get a prize to you. How do you win prizes? By participating. Talking in the chat, participating in the Q&A section, asking questions. All of these will help you in your chances to win a prize for participating in today's webinar. So please make sure you do that. But for now, we have all the boring admin stuff out the way. So I'm going to unmute Tiexin and hand it over to him in just a second. There we are. Okay, and I'm just going to change our slides. All right, Tiexin, I'm going to go on mute and I'll let you take it away.
Okay, can you hear me? Great. Okay. First, allow me to introduce myself a little bit. Yeah. I think maybe some people will still remember that I've been there it was about 1 year ago. I joined one webinar on Kubernetes. Yeah, this time it's a totally different topic, which is infrastructure as code. Yeah. So maybe first about myself. I've written a few lines here, but I'm not gonna read them all. Yeah, basically, I started my career as a backend developer. Did some basically backend full stack as well. Then I changed into the DevOps or cloud architect space because I want to get the big picture of how everything is working and deployed in the production environment. Yeah. So in the past 6-7 years, I've been mainly doing that. DevOps, cloud architect, stuff like that. Yeah, basically different companies call it differently, but basically I would say it's still the same. Yeah. Today I want to discuss infrastructure as code with you. As already mentioned, we will have a look at its definition, some benefits, choices of tools as well. Also, we will talk about a little bit best practices and some security topics. Okay. Without further ado, let's get started right now. First is infrastructure as code, the definition. Even if you don't know what is infrastructure as code, simply by looking at its name, it's not hard to infer what it is all about, right? So we are using code to manage our infrastructure. Or to put it in another way, infrastructure as code, or we call it IaC. It manages infrastructure in a descriptive manner, and the description is code. So the description is not documentation. It's not some steps of manual labor. It's not a series of commands to execute. And it's definitely not clicking your way through the graphic user interface. Some people even go far and say that the minute you click some button in your AWS console, you are already creating technical debt. I wouldn't really go that far, but I think it's actually true, right? So that's basically what infrastructure as code is all about. And since it's very important, why we are doing this? What are the benefits, right? So you might ask, why creating infrastructure manually is so bad that it's even frowned upon, right? So why is defining your infrastructure using code instead of, for example, an operation manual? Why is it so important? And actually, that's a very good question. And to me, the answer is very simple. Just one word: automation. For example, if you are creating many things in your testing environment, and maybe after thoroughly testing everything, you would like to clone the same stuff to your production environment. so that you know it will work for sure. But if you created the infrastructure manually in the first place, it would be really hard to clone everything into production, if possible at all, to create it again with exactly the same setup. Even if we had a really detailed documentation serving as a operation manual, things would still go wrong because we are humans, and humans tend to make mistakes. So
it's like the old, the old problem that we had. It worked on my machine, so then we started creating containers and virtual machines, and this is kind of like the similar thing. Oh, it worked last time I deployed it. It worked last time I set it up. We're taking the what ifs away and out of that equation.
Exactly, yeah. So if you are managing multiple environments, the chances are you are gonna clone one environment to another, at least on the infrastructure side, yeah. So even if you don't manage multiple environments, but still, infrastructure changes as time goes on. So you might need to add another server here and maybe some extra subnet there, or sometimes, especially for a local development environment, it's completely possible that you want to tear down everything and recreate. So the key is infrastructure changes all the time, and you need to create infrastructure all the time. And that's why automation matters. The purpose isn't really just to save some time, just to save a few seconds here and there. More importantly, automation makes sure you can create the exact same thing again and again without any like errors or something like that. Yeah, that's the benefits of infrastructure as code. And next, let's maybe have a look at some mainstream tools, I would say, for infrastructure as code. Yeah. Here I have a screenshot, a few names. Apparently, there are many popular choices these days, unlike in the very beginning, right? But first, I think I have to start with Terraform because it's a giant elephant in the room. I think it started in 2014, something like that. Terraform has been used by a huge amount of people, I would say. No matter in small startup companies or in large global corporations. During my professional career, I see it basically all the time. If we talk a little bit deeper about Terraform, it splits into two parts, I would say, logically. First is the core, and then there are the plugins, or maybe we call them providers. So the Terraform core is actually a state machine, which stores the current state of your infrastructure. And based on that, it can calculate what actions to take given the infrastructure code and the state. It does a comparison and calculated actions and do something. And the plugins or providers, then they are triggered or they are called by the core to do the actual like create, read, update, delete work. So this is basically Terraform in a nutshell. If you're using AWS, AWS has this tool named CloudFormation, but it's specifically for AWS and for AWS only. So I'm not going to talk too much about it because I'm not sponsored by AWS. Okay, yeah. I mean, if I was sponsored by AWS, I would still have my integrity and talk about more popular choices, right? So yeah, but I think I have to mention AWS again because they've got another infrastructure as code as code tool, which is the AWS CDK. Because it's polyglot. A polyglot means many languages. So basically, it allows you to define your infrastructure in any programming language. And by using a very specific special library called ggshield, your code can interact with JavaScript, which in turn calls the Cloud API. This means even if you're not a DevOps guy, for example, maybe you come from the backend team and you can only write some Python code, you don't really want to learn Terraform, but still you can write code in the programming language that you're already familiar with to harness your infrastructure. And that's the cool thing about AWS CDK or the ggshield library, yeah. Because it's so cool, then later Terraform also created this tool called Terraform CDK, or maybe I think it's called CDK TF officially, yeah, which is essentially the same, utilizing the power of the GSI library created by AWS.
Well, that's really interesting. So Terraform kind of created their own style of language. It was kind of like a declarative language, but you can actually create infrastructure using Python code, for example, with these CDK tools. I didn't know that.
Yes,
before.
actually,
That's really interesting.
Yeah. And recently, I think there is a new kid on the block, which is called Pulumi. It's also polyglot, but I think it's essentially different because it seems it's not using the GSI library as mentioned, but instead it has SDK for all the major programming languages. So it's a lot of work, I'll admit, but they've made it work. It's also a very contending choice, I would say. Yeah. But yeah. Sorry.
I just say I have a question about the polyglot. Is that part of the reason why infrastructure as a code was created was because basically to prevent that it worked last time I did it, as you know, as I was saying, to make sure that we could redeploy all the time and get the same results. If we're using different languages, couldn't we get different results that way? Wouldn't it make sense to use a centralized language, or is it just more that we use the same language each time we do it, so therefore it will be the same?
Yeah, actually, that's a very good question. So although AWS CDK or Terraform CDK or CDK-TF, although they are polyglot, but I think for certain teams, for your specific team, you probably would choose just one language for your team. For example, maybe you came from a front-end front-end background, I would say. Maybe you would choose Node.js. If you came from the backend team, maybe you would choose Python, Golang, whatever takes your fancy. Yeah. Normally, there is just one language across a team. You probably wouldn't want to do infrastructure as code using multiple languages in the same project. Yeah. Okay. But here I think we have listed a few choices, but I'm not going to say which one is the best tool because there simply isn't a one-size-fits-all answer to this question. You'd have to choose the best tool for the job, right?
Yeah.
Yeah, but I think because Terraform probably is one of the oldest, today I will put my focus on Terraform. Okay.
So that's a kind of a question moving forward now is what we've talked a little bit about what IaC is and how to do it and some different methods and tools to set it up. What are some of the best practices that we can adopt? I guess let's start with like when we're starting out. If we're entering into our journey of IaC, what are some of the best practices that we can adopt in the beginning? Okay, great. Then next, let's talk about a few, I would say, suggestions or practices for beginners. Actually, I have prepared for like 5 suggestions for beginners, all of which are related to either infrastructure or code itself. So this is the next slide. I have 5, so maybe let's go through them one by one. And the very first is to know your stuff, to know your infrastructure. For beginners with IaC, I do not really recommend using Terraform or any other tool immediately to create your cloud resources. Although when you click in the web console, right, so you are already creating technical debt, but it's still a very good idea to start playing with the cloud console itself. Try things manually, read the official documents, maybe FAQs as well. Figure out what parameters are mandatory and what are optional before actually writing some infrastructure code. I think the idea is to get familiarized and comfortable with infrastructure before you write code. Once you grasp the keys, you can automate it by writing the code. I know there are many like famous DevOps guys out there on the internet or on Medium, stuff like that. They say the moment you click a button in the console, you are already creating technical debt. I think it's true. I also said that maybe like 5 minutes ago. But when you're just getting started, forget about it. Learn the infrastructure itself before writing the code.
right? So you need to know exactly what is created and managed by your IaC code. And it is especially important when using some third-party code module because there are so many parameters and use cases. So it's very hard to know exactly which scenario to pick and what resources will be created and what values to set for those bunch of parameters, right? So that's my very first suggestion for IaC for beginners. So know your stuff. And next is clean code. Since the term infrastructure-as-Code contains two nouns, right? So infrastructure and code. Once you familiarize yourself with the infrastructure, the next thing to worry about is the code. Here I want to quote the computer scientist Knuth, because he once said programs are meant to be read by humans and only incidentally for computers to execute. And I totally agree, because the computer has no problem with ambiguous variable names, right? So extended functions or a single file with thousands of lines of code, it will still run properly. All the programming like techniques, for example, like refactoring, naming conventions, modules, and packages, and code smells, and etc. They are invented so that we humans can read the code better, not the computers to execute them better. They will execute anyway. So why is that important? Because programs actually evolve over time and the code changes. It is really rare that you finish the project and the code never changes, right? That's not how projects work. In order to make changes, in order to make the changes more manageable, we write clean code. Here, I'm not going to talk too much about how we write clean code, but in general, I think what we want to achieve is to make the code easier to read, easier to manage, and easier to change. Yeah. Maybe I can give a very simple example here. If we are talking about Terraform and infrastructure, when you are creating, for example, like a EC2 server in the cloud to test some services in your team, do not simply name the server like test server. Why? Because it's confusing. What is it used for? Test server for what? It's ambiguous. Here I suggest meaningful names. I don't really need to give more examples, but if we just think a little bit more before we actually write code, use our best judgment, I think the world would be a much better place. Yeah. So write clean code. That's my second small suggestion. Yeah. Next is a DRY or dry versus readability. DRY here means do not repeat yourself, and this principle is loved by many programmers, I would say. If you have like two similar features to implement, for example, with only one or two small differences, for example, some different parameters, and if you write two functions for each, you will end up if you write like one function for each case, you will end up with duplicated code. And using the right technique, for example, extracting the similar parts out of the similar functions and create a small module for it, that could be a better answer, I would say. But however, when you are achieving like many functionalities in just one piece of code, one module, you will need extra input parameters. You will write many like if-else's branches, right? But adding too many features into just one piece of code will invariably reduce the readability. Because although computers are very good at variables and if-else's, human brains are not. So what we need to do here is to find the right balance between duplicated code and readability. I think that's art here. It requires experience to make it perfect. And only you can make the decision for yourself. Forget about any like absolute rule. For example, maybe some people tell you you must have less than 10% of duplicated code. or reuse modules as much as possible. They are simply not pragmatic or helpful suggestions. You need to find the right balances for yourself. Okay, that's my third tip. And the fourth one is on future-proof, which means designing your infrastructure code so that it can still be used in the future. But the thing is, when you future-proof stuff, you will create more features you don't really need right now. You write if-elses, you write conditions, branches, so that your code could work for more than one scenario in the future. And which means if there are a lot of like a premature future-proof or even over future-proof, that will generate not so clean code. And for starters, we don't really want to introduce complexity when we don't really need it right now, because we can't possibly know exactly where we are going with it, whether we are going to need it in the future or not. Chances are, even if we did some future-proof, create some perfect modules and code in the future, when we really need to use this, we would probably refactor it anyway. And the future might not even come. So why future-proofing it right now, right? And there is my final tip for beginners, which is do one thing and do it right. So we want to do one thing well. I think for the audience who have already started with Terraform and maybe have browsed a few Terraform modules on GitHub, you probably have found that there are many examples of Terraform modules and code which try to be the complete package by supporting every single possible scenario. For more experienced Terraform users, you might already be familiar with this. For example, you want to make your module complete and useful in every scenario. You use some like complicated input variables, some structure. You even create more complicated local variables with shorthand conditions. You even need to use built-in functions to merge different variables as one. I think a lot of people know this based on their experience, but for beginners, when you read code like this, it's not really declarative and it's not easy to understand. When you read something as complicated as that, you can't possibly figure out what exactly is this piece of code actually doing, right? So this is also related to the DRY, or do not repeat yourself, in the previous slide, yeah. Because sometimes if your module only does one job, but does it perfectly, it might actually be good and easy to maintain without all those if-elses and variables. Okay, so I think these are my 5 simple tips for beginners, and I really hope they're helpful to you. Yeah.
So I'm keeping an eye on the chat. There's some really interesting discussions going on here, and there's definitely people that have surpassed that beginner level. There's kind of a lot of questions and answers being thrown around in there. What are some best practices for the people that are on the webinar that are very familiar with IaC, that have started, that maybe are even running it in production? You know, what are some more of the advanced best practices that we can implement moving forward from here?
Okay, yeah. I've seen a lot of questions in the comments. Maybe we will go back to them at the end of this session. Yeah. So maybe let's continue with Mackenzie's question. Let's talk about a few like best practices for people who are already familiar with Terraform or using Terraform in their production environment. Okay. Here I summarized like 3 principles. And the very first one is how to manage like multiple environments. Because when you are working on a real world project, unless you are working with a very simple personal project or a startup company at a very early stage, the chance is you run some tests before you actually deploy your application or infrastructure in the production environment. You have to test it first in some place like a development environment, or maybe you call it testing or staging. Different environments are separated from each other, and the separation makes your production environment more secure. And there will be no access coming from other environments to the production environment. And for example, the password, access keys, and etc. are different in all those environments. So if we make the right decisions when it comes to separating different environments, we are actually already halfway to a very secure infrastructure as code setup. And here I want to talk about the Terraform feature, which is called a workspace. And Terraform also has a state, which records the status of your infrastructure. And the state belongs to a certain workspace. You can use different workspaces to create a parallel or distinct copy of a set of infrastructure in order to test changes before modifying the main production environment. But the thing is, workspace is not really a suitable tool for system decomposition, because each subsystem would have its own separate configuration, state, and backend. So when we are using Terraform to manage larger systems, we should use multiple separate Terraform configurations so that different environments can be managed differently. Maybe we can share modules between different environments using different input variables and put the configuration for each environment in a separate folder, for example. Yeah. So that would be my very first suggestion for, I would say, veteran Terraform users. So workspace is useful, maybe use it for testing, but do not use it to manage multiple environments. For managing multiple environments, try to use modules and try to use different directory structures for each different environment. Yeah. My second best practice here, let me turn to the next page, doesn't work. Okay. Can you do that for me, Mackenzie? I'm clicking on the next page, but nothing happened. Yeah.
Give me 1 second. I'll take over in just a minute. I'm going to have to do it there.
Doesn't work.
No, it's just going to have to do it a little bit dodgily because I can't. I only have the PDF. I don't have the slides. But this will be fine.
Okay, I think now it's okay. Yeah.
Okay. Got it.
Maybe there's some lag. Yep. Yeah. Okay. Yep. So yeah, next I want to talk about infrastructure as code and configuration management. To be specific, how to separate IaC with configurations. So IaC manages infrastructure in a descriptive model, I would say. So you write your code to manage your, for example, networks, servers, load balancers, and etc. Configuration management, on the other hand, they maintain computer systems like software, dependencies, settings, and etc. Yeah. If we think about the physical data center as example, we want to purchase some servers, putting like a newly purchased server onto a rack, installing the servers, connecting networking cables to the switches so that it's connected to the existing networks. This kind of stuff belong to the definition of infrastructure. These are infrastructure parts done by specific infrastructure team. But in contrast, after the server is launched, configuring the server to run, for example, a specific application, installing, for example, HTTP server or software, or configure it to be in some specific state, and that kind of stuff belongs to configuration management. And they are probably done by another team, which doesn't need to worry about the underlying infrastructure at all. So in the real world, actually things are not so simple as black or white, as example we just gave above. Yeah, because there are tools which can do both. Like Terraform, you can also do some configuration management, or like Ansible, it can also do some infrastructure, especially on the cloud space, right? So finding the right balance between these two and finding the right boundary, yeah, figuring out which part you would like Terraform to do and which part you want your configuration management to do. And I think that's very crucial, especially for larger projects. Because in an ever-changing world, the entropy of your system is only going to increase. In the long run, you will benefit more. You will benefit greatly from simplicity and do one thing and do it right. So let each tool handle like what they does the best, right? And that wraps up my second best practice. And the third one actually here is a picture. I think it's too small. Maybe someone can see. Basically, this picture here means idempotency. Idempotency, I think, is a math concept borrowed into the programming world. Basically, it means if you apply the function twice or 3 times, doesn't matter, you can get the same result. For infrastructure, it's actually the same. It means no matter how many times you run your infrastructure code, and regardless of your starting state, you will always end up with the exact same result. Idempotency is nice to have because infrastructure is not getting simpler as time goes on, as we already mentioned. Even if you just started fresh, you will handle like complicated scenarios, situations in no time. Idempotency simplifies the provisioning of infrastructure, and it reduces the chances of inconsistent results, I would say. For example, if you need to set up something, you need to set up this service A first, then you need to set up B after A is completed. But if setting up A fails, you want to rerun your automation so that it can retry the setting up without trying to create A again or something like that. Because if it tries to create A again, it will fail because A already exists. That's the kind of thing idempotency tries to solve. For example, if you run some commands with Terraform, we can run some bash command with Terraform, right? So, but maybe if the command returns you an error, right? Which means in order to make the whole infrastructure code idempotent, you have to think in a declarative way. So you don't really run commands to do this. That's the imperative way. You try to think the code as a declarative way, which is to describe the final state you want to be in. And that's the key thing for Terraform, because you will always fail. Even there is some like network jitter, your Terraform apply would fail. You want to rerun everything, and you do not want to let the previous state cause a different result. That's why idempotency matters here. Yeah. So these are the 3 best practices, or I would say best practices, I would say, for real-world Terraform projects. Yeah. I'm pretty sure veteran users are already familiar with it, but still I'm happy to share them with you. Yeah.
This is really interesting, particularly someone that's not a veteran user. There's a lot of discussion happening in here. I think we have about 25 questions that have been answered, that have been asked. So we will try and get to them at the end. We'll try and move quickly. But the GitGuardian is a security company. The webinar here is about security. We've talked a lot about best practices. Let's now hone in on security. What are security risks with using IaC, and what are some best practices that we can use specifically in dealing with the security of our infrastructure?
Okay, great. Then next, let's continue with security. Actually, I have prepared a lot of content here. I had basically 2 major sections. The first of which is on Terraform itself, and the second part is mainly on the cloud infrastructure. But because I think there are so many questions, maybe I will just skip the second part. I will talk mainly about the Terraform issues I prepared. Then maybe later we can go back to the questions and I'll try to answer some. Yeah. So regarding security in Terraform, the very first thing I want to talk about is actually the sensitive input. Because since infrastructure-as-Code create infrastructure, right? Sometimes they will contain sensitive information. And on the next slide, I have I have an example here. Maybe it's also too small, right? If you can't see, it doesn't matter. Basically, it's a definition of a variable, which is a DB password, which contains the database administrator's password. So if nothing special is done about it at all, when we actually run the Terraform code, when we try Terraform apply, the password will be printed out. And that's bad because we don't really want some other people passing by and accidentally see my screen and see the database admin password. And luckily, there is a solution in Terraform. And I think this feature was introduced a few versions before, which is a sensitive flag, as shown in the first screenshot. So if we make the variable, or maybe it can also be an output as sensitive, it won't be printed out when you do Terraform plan and apply, just as the second screenshot shows. This might be a minor issue, very easy to fix, but actually it's very important because it doesn't show sensitive information at all. Okay. The thing is, we need to remember that even if the variable is declared as sensitive, it's actually still stored in the state, because the state actually needs to know the variable's value or the output, so that if it's changed in the future, next time you do Terraform apply, it will do something about it. It will generate different actions. As shown in the next slide, I have a piece of Terraform state, and when we try to grab the password, we can see the password actually is stored in the state. So the Terraform state, it contains highly sensitive data and should be put at a secure place. Previously, actually, I've written some blogs about data security, especially security in transit and security at rest. If you are interested in this topic, maybe you can go to GitGuardian blog or my personal Medium channel to check them out. Yeah, here is a hard advertisement. Okay, sorry for that. Yeah.
Thank you. We appreciate it.
Yeah. Okay, and the second thing I want to talk about infrastructure security is do not store sensitive in the code at all. So if we think about the previous example where we defined a variable which might be a database administrator's password, right? We declare the variable with the sensitive flag enabled, but it's still not secure 100% because we need to set the value for the password when we try to do Terraform apply. That's just the variable definition, and we want to assign some value to it, right? So where do we store the value? How do we assign the value to it, right? If we store the value in Terraform like a variables files, something like something.tf vars, right? The password is still in the source code, and that's bad. Because the database password basically is public to anyone who has read access to this IaC repo. So here, maybe we can store the values of those sensitive variables as environment variables, which technically could work. But I think that's personally, to me, that would be a lot of work, because every time when I need to do Terraform apply, I need to export a lot of environment variables. Yeah. And also, actually, I think it doesn't really solve the problem at all, because you still have to store those values somewhere. Where do you store those values? Don't tell me you want to write those down on a physical notebook, right? That's not possible. Yeah. So here we need something better for storing those sensitive data. And luckily there is. We can use secrets managers. And the secrets managers can integrate very well with Terraform. Basically, you store the values of those sensitive data in a secret manager, and you can read those information directly from Terraform and using the values from the secret managers. But today, I think there will not be enough time to be giving examples about using secret managers. Yeah, but again, I've also done some blogs on this topic. Feel free to read them on my Medium channel or GitGuardian blog. Yeah. Also, I think later Mackenzie will do a live demo to help you identify like potential security issues in Terraform code, like secrets
Yes.
stored in a source code file, right? So yeah, maybe let me
Definitely.
handle this back to you. Would you give us a short introduction, then some demo?
Sure, absolutely. Let's do that. I'll just take over on my my screen. Tiexin, can you mute your microphone for a minute, just because I'm getting some. Thank you. Okay. So you should be able to see my screen here. I've removed myself. I didn't mean to do that, but let me see if I can bring myself back. There we go. Okay. I'm going to be very, very quick here because, and I'm going to show you something, some very, very basic things because we're running out of time, and I do want to get to some of the questions because the main appeal here is, of course, Tiexin. But I have here. This is a project that we have that uses Terraform and AWS to basically to deploy a backend here. Now, this is quite a simple project, but simple things can really cause big problems in security, particularly when we've got infrastructure as a code. I'm not sure exactly why, but if we look at some recent security incidents, S3 buckets being misconfigured, basically S3 buckets, which is a data storage system being made public, is this so prevalent in security breaches? It's kind of ridiculous and scary at the same time. So 3 terabytes of sensitive airport data was leaked recently. And we can go through that because there's no shortage of any breaches that we have through S3 buckets. So if we use this one concrete example, what's something that we can do to be able to prevent this? And really it's quite simple. At GitGuardian, we have an open source tool called ggshield. And we have an infrastructure as code module of this. So if you see my screen here, I'm running the command ggshield IaC. I'll try and make it a little bit bigger. We're going to scan, and I'm going to use dot because I want to scan my entire directory. So what does this do? This looks at our Terraform files, and it comes back if we have any issues. So right now we have here that it's got an issue that I have an S3 bucket that has public access. The severity of this is high, and it gives me a code next to it. So I can actually look on some of the GitGuardian documentation how to fix this. But of course, because I know, this is as simple as adding a policy in here to restrict public buckets. And then if we save this and run the same command again, we will get, hopefully, no incidents being found. That's a very simple example. And yes, we know we shouldn't make our S3 buckets public, but hey, this happens all the time. So we can automate some of these checks. And it's not just areas like that. Here I have basically the equivalent of a hello world example. This might be something that you first start off doing when you're deploying it. What this application does is basically just deploys a website using AWS. But this is basically where we're going to start. So a lot of people might be wondering, okay, how do I even know what security vulnerabilities I have? Because a lot of defaults can be insecure. So if we run the same command here, ggshield IaC scan dot, this is going to scan this project here. And this is going to give me a lot of all the incidences that I have that are wrong. And what this does is we can now go through one by one and figure out the fixes for this. There's good documentation about how to kind of fix all these on GitGuardian. And we can automate these scans too. So this just adds another layer of protection for scanning our infrastructure. So that's basically, just one area. This is only focusing on security. So when we're talking about best practices and other areas like that, absolutely follow Tiexin's advice. But this is kind of the demo of kind of one area of how we can start preventing some of our security incidences here. Tiexin, I'll bring you. I'll leave it there because I don't want to take up too much time of that. But basically, anyone can check out ggshield. It's on GitHub. You can or you can use your pip as a package manager or brew to install ggshield, depending on what you're doing. I'll bring back Tiexin's slides. Give me 1 second. I'll just figure us out. There we are. And I'll leave it back over to you, Tiexin, to continue on.
Okay, actually, I have yet another section left, which is cloud infrastructure security issues. But I think since we're already like 50 minutes into this webinar, maybe shall we look at some questions?
Let's do a quick. If you give us a speed rundown of it, and I'll start preparing some questions that we can answer now. So just a reminder to everyone, on the right-hand side, there's a Q&A section. You can upvote questions. So there's plenty in there. If you want a question answered, make sure you upvote it yourself. But Tiexin, if you, maybe just a very quick, can you give us a quick slide through while I figure out some questions to answer?
Okay, then let me finish my slides anyways, yeah. So on the next few slides, I will mainly talk about like securities for AWS or maybe for another cloud provider. Doesn't matter, the principles apply, yeah. So when you just started with your cloud journey, maybe you have a root user which can do anything, yeah. The practice here is to disable the root user and use admin users and admin groups. Root user is very dangerous. It has all the privileges, can do everything. Yeah. So the first rule is to disable the root user, create admin users, admin groups. And you want to also set up like very strong password policies. Maybe also rotations as well. Basically, you need to do this not only for the cloud, but for everything, right? Interesting next is cross-account access. So maybe in a medium to large-sized team or company, using a multi-account strategy is more common to secure resources to achieve the maximum resource separation and the precise permission management, right? I've also seen some comments in the chat. It's very common to have like different structures, different folders for different environments, and it's also common to use different accounts for each environment in an organization. So you want to, if you create a user in each environment, in each, then each user might have like multiple accounts. Of course, we can use Terraform to automate the process. But there are still some major drawbacks, right? So each person having multiple accounts is hard to manage. You also need to create different sets of Terraform scripts, one for each environment. And the solution here actually is to use a central account and only use users there. For other accounts like dev, test, prod environment, we can grant access to the users inside the central account. So the central account users assume the role to each environment. This is considered as a best practice for different cloud platforms, I would say, yeah. And yet another simple one, this is actually a very detailed example. If you're using some virtual machine services, chances are you have deployed some apps, and those apps might need access to other cloud services. If you use like password or like API keys, it's very hard to manage, but it's safer to use, for example, in this case, IAM role basically, which is attached to the virtual machine instance, which allows the virtual machine to do everything. Yeah. And my final comment would be on the just-in-time access. So even if you have a Terraform, chances are we still need to create some temporary users for like one-time access, like a data engineer needing temporary access to S3 bucket to verify some data. But that's just a one-time job, right? Here, maybe we can utilize something like HashiCorp Vault which has a like AWS secrets engine, which can do the creation and the destroy automatically with timeout. Yeah, because we are running out of time, I will also not dive too deep into this. I will not dive too much into this topic. Interested, read my blog, GitGuardian blog, or my Medium channel. I think I need to clarify here. I promise you, neither Mackenzie nor everybody, nor anybody at GitGuardian asked me to talk so much about GitGuardian blog. Okay, it's just that I write a lot of blogs. I'm not sponsored in any way. Yeah. Okay.
Oh, yeah. Well, we love you. Hopefully if someone from GitGuardian is listening, can you guys post a link? If we can get a link to just Tiexin's blogs, that would be amazing. I'm not sure if that's possible. But to get them in there, because Tiexin has some incredible articles on GitGuardian that shares his knowledges. But we have a few minutes left. So Tiexin, thank you so much. But let's get some strategy, some questions here. So we have the first one here. What branching strategy do you recommend to infrastructure as code?
Okay. To me, I think no matter if it's infrastructure code or just normal code, I think different teams use different strategies. Some teams, they prefer to deploy everything from the main branch. They don't really use a different branch for different environments. Of course, they would still use feature branch for testing, but the feature branch needs to be merged into the main branch before they are deployed in each environment. There is also another pattern, which is to deploy each environment from a certain branch. You have the main branch for production. Maybe you have a developing branch for development environment. I think that's the same thing in infrastructure as code. It's just code. So different teams have different preferences. I couldn't say which is best. But if we are following the directory structure, for example, as mentioned in the chat, maybe you have a different folder for each environment, then I think it makes less sense to create different branches for different environments. Because since the configuration for each environment is already separated, you can just deploy everything from the main branch. But of course, always test before deploying in production. Yeah, that's my answer.
Okay, great. We'll move on to the next one here. Where is the right balance for predefined custom roles in cloud IAM? So the question's been cut off here. But essentially, we need to follow the least privilege rule, but it's harder to maintain custom roles, especially with infrastructure as code, when changes could often be and not from the infra team. So what is the right balance for predefined custom roles in cloud IAM when using infrastructure as code?
Okay, here I think it depends. Yeah, there is still no right answer. I'm feeling like all this evening, I didn't really give much helpful suggestion because I don't think there is a one-size-fits-all answer. You still have to figure things out by yourself. Least privileges, I think that's the base upon which we are building everything, right? Which is good. And for example, AWS or some other cloud providers, they do have like predefined, predefined roles already. But sometimes you would still want to create custom roles. I remember that in the very beginning when we were doing, for example, Kubernetes clusters, we need to define at least 2 roles, one for the control plane, one for the data plane, which is attached to the virtual machine instances. Back then, I don't think there was really some like predefined roles. That's why we had to go over the permissions, create the custom roles, and attach them to the data plane and control plane. But maybe things have evolved since then. So maybe there are like perfectly predefined roles which meet the least privileges requirement. Yeah.
Oh, sorry. I think you cut out. I thought you were finished, but maybe you just cut out on my computer. Number 4, how to deal with privileged service accounts to deploy infra from IaC? Its potential point for attack and easy to use for lateral movement.
Yeah, I think this is a great question because just recently, I think LastPass was hacked, right? Because a DevOps guy has a permission to deploy everything, and yeah, the hackers got started from there. And I think that's a key thing. Maybe you should not run your infrastructure code from a personal laptop or something like that. Maybe you should run it from a continuous environment, continuous integration, continuous deployment, maybe even Terraform Cloud, which is a controlled space. You can control the permission much closer, and there is less risk compared to human errors, right? So I think that might be an answer. It's worth exploring, yeah.
Okay, great. We have a couple more questions, but as we're kind of coming to the end of time, I'm just going to quickly say, in case they have to go, congratulations to Anish and Nunnan. I'm not sure if Nunnan, I'll email both of you guys, or both you guys or girls, to let you know that you guys have both won a prize. I'll email you with some more information about that. But congratulations to you both. But whilst we're still here, I'm going to sneak in a couple more questions, if that's okay, Tiexin. I know it's late. It's 1 a.m. now for Tiexin, but there's some really great questions that I want to take advantage of you while I have you. How do you see the ideal set of tools for checking the security of IaC?
Okay, here I think first of all you need something to check like secrets from your source code. I think this sounds dumb, but a lot of errors actually happen because humans make mistakes, right? So checking your source code, making sure there are no like critical information. I think this would be a very good start. And try to use secrets managers, as we mentioned. Yeah. As for others, I also saw from the chat, a lot of people has mentioned, for example, some TF-lint tools like that. They also integrate some great rules. They can give you suggestions. Sometimes they are security related, sometimes not, but still they are of great help. Yeah.
Yeah, and I'll add in there ggshield is also another good one. We'll slid in one more question here. Do you think solutions like Plumi can be considered riskier because you've access to all the features of the supported languages, as opposed to being limited by a language like HCL that focuses you to be more declarative? So do we think that, having the multiple language solutions could actually be a security risk, I guess because of its extended abilities?
Okay. Although HCL, I wouldn't say it's a real programming language because there are limits, right? Like if I remember correctly, before like 0.12 or 0.11, it's really hard to do a for loop on the modules level. So I wouldn't really say HCL is a programming language. It has limited capabilities, I would say. But still, it's something new. Since it's a language, there will be like security issues, just like any other programming language. So if we talk about things from the security standpoint, I don't think if you write your code in Python is riskier than writing your code in HCL, because HCL itself, although limited, it still could have like potential security issues. Yeah, but I think here is actually right, because maybe Plumi isn't really declarative, because most code really isn't. But if you write in HCL is more like I would say it's more similar to YAML than it is to Python, I would say. So when you read your HCL, you know exactly what you are creating. But if you're reading a piece of Python Node.js code, you'll see a lot of loops. You'll see some even calls directly to the cloud APIs. I think it's harder for humans to understand. So if you want the extra flexibility, maybe Plumi is great. But if you are more than happy with the declarative way HCL provides you, maybe Terraform is a better choice for you. Yeah.
Well, Tiexin, I think we've run out of time. We've got a lot of questions here, but I think it would take us another hour to get through them all. But people clearly found what you said very fascinating and interesting. So thank you so much for being here, as particularly seeing that it's in the wee hours of the morning. And I'm sure I speak for everyone that was on the webinar that it was fantastic and gave great content. And just one thing, just if I could flatter you for a little bit more, this has been one of the highest retention webinars that we had. We had hundreds of people join at the start, and we had hundreds of people remain at the end. So I think that shows a lot about the information that you said. So thank you so much, Tiexin. It's been a pleasure, and I really enjoyed it.
It's my honor. Yeah, happy to be back. Thank you.
All right, everyone. Just a public service announcement before we go. The State of Secret Sprawl 2023, which is GitGuardian's annual report that we release. It's probably what we're most well known for. I want you all to know that this is going to be released in a couple of weeks' time. March 9th is a tentative date. You can sign up for this and be alerted when it goes live. And next month's webinars, March's webinar, is going to be on the State of Secret Sprawl report. It's going to be great. So make sure that you follow us on Crowdcast. If you go to the State of Secret Sprawl, you will be able to, if you type that into Google, you'll find a wait list where you can be emailed the report as soon as it comes out. It's going to be fascinating. I've had a sneak peek. I can tell you there's some unexpected things in there this year. So please make sure you stay tuned for that. Follow us on Crowdcast so you get notified of the next webinar.